Welcome to the bilingual e-lectures for diploma students sponsored by Directorate of Technical Education on linear integrated circuits. So, in this lecture series, this is the last lecture and we are going to conclude. So, whatever we have discussed so far in this module. So, in this module, in the previous module I was discussing about phase locked loop. So, I am going to continue the applications of the phase locked loop in this module. So, we discussed in detail about the working of PLL in the previous module, right. So, now let us discuss for the application. So, once again let me repeat the recall the function working of the PLL in this module. So, the PLL எப்படி வேலை செய்யுதுன்னு ஒரு இந்த மாடலில் நம்ம லேசாக சொல்லிடுவோம். ஸோ PLL வந்து ஃபேஸ் கம்பேரட்டர் இருக்குது, வோல்டேஜ் கண்ட்ரோல்டு ஆசிலேட்டர் இருக்குது, லூப் ஃபில்டர் இருக்குது. ஸோ எய்ம் ஆஃப் த PLL இஸ் டு மெயின்டைன் தி ஸ்டேபிள் ஃப்ரீக்வன்சி அட் தி அவுட்புட், ரைட். ஸோ ஃப்ரீக்வன்சி ஷிஃப்ட் ஏதாவது வந்ததுன்னா அதில் உள்ள எரர் ஃப்ரீக்வன்சிக்கு ஏற்ற மாதிரி வோல்டேஜை ப்ரொடியூஸ் பண்ணி ஃபேஸ் டிடெக்டர் வோல்டேஜ் ப்ரொடியூஸ் பண்ணி அந்த வோல்டேஜுக்கு ஏற்ற மாதிரி ஃப்ரீக்வன்சி அட்ஜஸ்ட் பண்ணி டியூன் பண்ண போகிறோம், ரைட். ஸோ PLL யூஸ் பண்ணி ஸ்டேபிள் ஃப்ரீக்வன்சி ஜென்ரேட் பண்ண போகிறோம். ஸோ அது வந்து கம்பேர்ட் டு த ரெஃபரன்ஸ் ஃப்ரீக்வன்சி, ரைட். ஸோ ரெஃபரன்ஸ் ஃப்ரீக்வன்சி இஸ் ஜென்ரேட்டட் த்ரூ த crystal oscillator stable frequency. It is given to the phase detector. So voltage control oscillator output is also given to the phase detector. So இந்த ரெண்டு ஃப்ரீக்வன்சிக்கு உள்ள டிஃப்ரென்ஸ் இன் ஃப்ரீக்வன்சியை சென்ஸ் பண்ண போகிறோம் பை மீன்ஸ் ஆஃப் ஃபேஸ் டிஃப்ரென்ஸ். நேரடியாக ஃப்ரீக்வன்சி டிஃப்ரென்ஸை பார்க்கல, ஃபேஸை பார்த்து ஃபேஸ் மூலமாக ஃப்ரீக்வன்சி டிஃப்ரென்ஸை எஸ்டிமேட் பண்ண போகிறோம். ரெண்டுக்கும் இடையில் ரெஃபரன்ஸ் ஃப்ரீக்வன்சிக்கும் VCO அவுட்புட் ஃப்ரீக்வன்சிக்கு இடையில் ஃபேஸ் டிஃப்ரென்ஸ் வந்து கான்ஸ்டண்ட்டாக வந்தால் இது ரெண்டும் சேம் ஃப்ரீக்வன்சின்னு அர்த்தம். வேரி ஆச்சுன்னா ஃபேஸ் டிஃப்ரென்ஸ் வேரி ஆச்சுன்னா இது ரெண்டும் டிஃப்ரெண்ட் ஃப்ரீக்வன்சின்னு அர்த்தம். ஸோ அதை பொறுத்து கெட் த பல்சஸ் ஹியர். So the output of the phase detector we will be able to decide whether these two are same in frequency or different frequencies, right. So pulse width vary ஆச்சுன்னா frequency ரெண்டு டிஃப்ரெண்ட்டு, சேமாக வந்துச்சுன்னா கான்ஸ்டண்ட்டாக இருந்தால் சேம் ஃப்ரீக்வன்சி. ஸோ எப்போல்லாம் டிஃப்ரென்ஸ் வருதோ தட் மீன்ஸ் ரெண்டுக்குள்ள டிஃப்ரென்ஸ் ஃப்ரீக்வன்சி வந்து எரர். ஸோ அந்த எரரை குறைக்கிறது இல்லாட்டி சரி ஜீரோ ஆக்குறது அந்த PLL உடைய எய்ம். ஸோ எப்படி ஜீரோ ஆக்குறோம்னா அந்த எரரை வோல்டேஜை மாற்றுறோம் யூஸிங் த லோ பாஸ் ஃபில்டர். ஸோ யூ கெட் த எரர் வோல்டேஜ். ஸோ ரெண்டுக்கும் எவ்வளவு டிஃப்ரென்ஸ் ஃப்ரீக்வன்சி வருதோ அதுக்கேற்ற மாதிரி வோல்டேஜ் வருது, ரைட். லோ பாஸ் ஃபில்டர் மூலமாக வோல்டேஜை மாற்றுறோம். இந்த வோல்டேஜ் வந்து VCOக்கு இன்புட்டாக கொடுத்து இந்த வோல்டேஜுக்கு ஏற்ற மாதிரி ஃப்ரீக்வன்சி அட்ஜஸ்ட் பண்ணுறோம். when error voltage increases it decreases, when error voltage decreases the frequency increases. So by adjusting the error voltage we are adjusting the output frequency equal to the reference frequency. Simply we are making the error in frequency 0 or minimum level. So this is what the working of PLL, right. So that's what simply we are calling it as a capturing. That means நம்ம அட்ஜஸ்ட் பண்ணும்போது இதை கேப்சரிங் மோடில் இருக்குன்னு சொல்கிறோம். ஒன்ஸ் அட்ஜஸ்ட் பண்ணி VCO அவுட்புட் வந்து ரெஃபரன்ஸ் ஃப்ரீக்வன்சிக்கு ஈக்குவலாக ஆயிடுச்சுன்னா PLC லாக்டு ஸ்டேட்டுக்கு வந்துருச்சுன்னு சொல்கிறோம். தட் மீன்ஸ் we are locking the output of this frequency VCO to the reference frequency. இவ்வளோ தான் இதோடைய ஒர்க்கிங் பிரின்சிபல், ரைட். நவ் let us discuss the application of the PLL. One of the important application is frequency multiplier, right. இப்போ இந்த PLL frequency multiplier யூஸ் பண்ணலாம் எப்படின்னு பார்ப்போம். ஸோ நம்ம ஏற்கனவே PLCயோட ஒர்க்கிங் பார்த்துட்டோம். now what about the frequency multiplier? See VCO frequency output, the output of this VCO is my output frequency, right. இதுதான் நம்ம இந்த output of the VCO தான் வந்து PLL ஓட output frequency. அது ஸ்டேபிளாக இருக்கணும், ரைட், irrespective of the noise changes as well as the temperature changes. அப்போ அது நம்ம என்ன பண்ணுறோம்னா இது வந்து வெரி ஹை ஃப்ரீக்வன்சி. யூஸ்வலி VCO output is a very high frequency. I want a very high frequency here, right, but my reference frequency is a low. So in that case I can use this PLL as the frequency multiplier. Say for example my reference frequency is a 2 megahertz signal, but I require 10 megahertz signal. So what can I do? I have to multiply it 5 times, right. At the same time I also have to maintain the stability. I need a stable very high frequency, right. so I am going for the frequency multiplier. இப்போ என்ன பண்ணலாம்னா இப்போ வந்து எனக்கு வெரி ஹை ஃப்ரீக்வன்சி வேணும் பிஎல்ல யூஸ் பண்ணி ஆனால் ரெஃபரன்ஸ் ஃப்ரீக்வன்சி லோ. ஸோ அந்த கேஸில் நம்ம இதை ஒரு மல்டிப்ளையராக யூஸ் பண்ணுறோம். எப்படின்னு பார்ப்போம். ஸோ ஃப்ரீக்வன்சி வெரி ஹை ஃப்ரீக்வன்சி can be generated at the VCO output, right, by locking it. So what we are doing is let the F0 is the output frequency of the VCO. F0 தான் VCO ஓட output 10 megahertz னு வெச்சுக்கலாம் எக்ஸாம்பிளுக்கு. ஸோ எனக்கு வந்து இங்கே ரெஃபரன்ஸ் ஃப்ரீக்வன்சி only 2 megahertz தான். ஸோ ஐ கேன் கம்பேர் திஸ் 2 megahertz சிக்னல் ரிலேட்டட் டு தி 2 megahertz ஓட தான் நம்ம கம்பேர் பண்ண முடியும். ஸோ ஸ்லைட் சேஞ்சஸ், ரைட். ஸோ ஃப்ரீக்வன்சி எரர் cannot be this much, ரைட். அப்போ என்ன பண்ணுறோம் அப்படின்னா ஸோ இந்த பேண்ட் லிமிட் லாக்கிங் எப்போ வந்து பிஎல்எல் லாக் பண்ண முடியும்னா ஒரு பர்டிகுலர் பேண்ட் ஆஃப் ஃப்ரீக்வன்சிக்குள்ளே தான் லாக் பண்ண முடியும். தட் இஸ் நாட் வெரி மச் வைடு. ஸோ 2 megahertz 10 megahertz பண்ண முடியாது. ஸோ எனக்கு தேவை வந்து அவுட்புட் வந்து 10 megahertz, பட் ரெஃபரன்ஸ் ஃப்ரீக்வன்சி ஒன்லி 2 megahertz. ஸோ வாட் ஐ கேன் டூ இஸ் டிவைட் தி 10 megahertz by 5, ரைட். ஸோ divide the input frequency by a factor n. So in example la vandu 10 divided by 5 I get 2, right. So n divided by n network, by employing the divided by n network here to divide the input frequency by the factor n, you get the f0 by n, right. Now it is comparable. So phase detector compares these two and find the difference in frequency in terms of phase variations, and it is converted into a voltage and amplified voltage given to the VCO, and VCO adjust and lock it to the 10 megahertz, lock it to the F0, right. So finally at the output I am getting 10 megahertz, but using the 2 megahertz reference frequency, right, because I am using here a divider network like that. So input frequency F in, it is a 2 megahertz, and using this divider network I can make it into a 10 megahertz divided by 5. Similarly, this input frequency can be multiplied by n factor n. Input frequency can be multiplied by factor n and available at the output, right, using this configuration, this method. So it is called as frequency multiplier. The idea is very simple. So your input frequency is the PLL locked to the input frequency, reference frequency, by employing the frequency divider network here, right. So if you this n decides the n is the actually multiplication factor, right. So by what factor you want to multiply your input frequency, that network you have to select here, divided by, that is frequency divider, right. So you have to select the frequency divider with the factor n according to your requirement. Okay. So this is one of the application of the frequency multiplier. You can see here, see once again this, with this diagram you will be able to understand very clearly that each output, see for example this is your voltage controller, right. This is your voltage controller, controlled oscillator, voltage controlled oscillator VCO. So the output is divided by the frequency divider network dividing factor n, okay. So this is actually a multiplication factor of the entire circuit. So here we are dividing it by n and you get the signal here, and these two we are comparing. This is the reference frequency, this is the frequency divided by the divider network from the VCO, right. Now phase detector compares these two, see it compares, there is a phase difference between these two signal, right. This phase difference based on the phase difference, if the phase difference varies, that means difference in frequencies, right. So on the phase difference you are getting here as at the output phase detector. So now the width of this pulse is proportional to the difference between these two signal phase, okay. The width of the output of the phase detector, see at the output we are seeing the pulse, right. So the width of the pulse is actually representing the phase difference between the two input signal, okay, fine. So now it is converted into a voltage, DC voltage it is given to the loop filter is nothing but the low pass filter which converts this pulse into a DC voltage, and error voltage, this is given to the voltage controlled oscillator. See, if it increases, if it is a positive, the frequency will be decreasing. If it is negative, the frequency will be increasing. That is the actual adjusting the frequency, right. So, the frequency divider network is inserted between the VCO and phase reductor to get the frequency multiplier circuit. The output frequency divider is locked to the input frequency F in. The VCO is actually running at the multiple of the input frequency. The desired amount of multiplication can be obtained by selecting the proper divided by n network. See here, we are using the, here we have constructed the frequency multiplier circuit using monolithic PLL LM565. So, about this particular chip in our earlier module we have discussed already. Now, here we are using this monolithic PLL 565 to construct the frequency multiplier. So, what we have done here, see, we know that the output of this particular pin 4 is the PLL output. It is the output frequency actually coming from VCO is divided by the frequency divider network. This is 7490 is nothing but the counter circuit. This can be set to divide by n counter mode. So, this will divide the input signal, actually here the input is given here, right, input to the 7490 is given from pin number 5, okay, and it divides the frequency by the factor n. So, accordingly you have to set this chip, and finally you get the output. Here it is given through a see, yeah, it is given to the, actually the divided signal is given to the 5 through a transistor circuit, okay. Actually the signal coming from here through the transistor, why transistor is here, because simply it increases the current. So, signal is given in the base mode and taken out at the collector mode, and it is given to the through the dividing network, frequency dividing network to the PLL, okay. So, by inserting this frequency divider network in between the VCO and the phase reductor input, we are getting the frequency multiplier, that is all. Remaining circuitries are same, that we have already discussed about. This is the input voltage, by adjusting the voltage you are able to adjust the output frequency, and all these things we have already discussed. So, between pin number 4 and 5 the loop is broken and the frequency divided by n network is inserted. In this case we have connected IC 7490 as divided by 5 network, okay. And the output of the VCO at pin number 4 is not sufficient to drive IC. So, a transistor is used in between to increase the drive, to increase the current. So, this transistor is in common emitter configuration. So, the current gain is more, output current is more than input current, that is the emitter current is alpha times the greater than the base current. So, the current gain is high. So, the output VCO frequency can be varied with the help of R1, okay. We already learned that R1 you can adjust the timing by the external resistance R1 and C, but C you can have any value, but R1 you can set between 20 kilo ohm, 2 kilo ohm to 20 kilo ohm only, right. So, keeping any value in between this and proper value in C1, you will be able to vary the output frequency of VCO. So, minimum output frequency of VCO, the expression is this, right. So, 0.3 divided by R1 max, that is R1 C1 capacitance, external capacitor, resistors and capacitor. So, if you put the 22 kilo ohm, right, and 0.1 microfarad, you will get this frequency minimum, and this is the maximum frequency at the output of VCO you can get. Thus, the output frequency can be varied from 1.3636 kilohertz to 15 kilohertz with a single capacitor. The input waveform can be square wave or it may be a sine wave, right. Square wave output you are getting at pin number 3 and sine wave at pin number 2. Yeah, you can also have a small capacitor of 1000 picofarad connected in between pin number 7 and pin number 8. Pin number 7 and pin number 8 we are connecting 1000 picofarad capacitor for to reduce the parasitics, transient parasitics. So another important application is frequency translator. Okay, so we have discussed frequency multiplier, how PLL can be used as a frequency multiplier simply by connecting the frequency dividing network at the VCO output and between the VCO output and comparator input. Now what is frequency translator? It is also called as frequency synthesizer. In some applications we want to shift the input frequency by a small amount, not by multiple numbers. Okay, say for example your input frequency is at 2 megahertz. If you want to multiply it by a 10 megahertz, so you need to construct the frequency multiplier circuit. 5 times you have to, in the multiple of input frequency you have to increase 5 times, but that can be done by frequency multiplier circuit. Multiplier circuit வச்சு அந்த application பண்ணலாம். But இங்க வந்து not in terms of multiple number, with slight deviation from the input frequency. Say for example if your input frequency is 1 megahertz, I want translate to 1.2 megahertz, some fraction of it. Yes, it can be done. That circuit is called frequency translator circuit, also called as frequency synthesizer. It is useful in communication systems, right? So if your input frequency simply it will shift the input frequency for a small amount of time. The shifted frequency is called FT, that is translated frequency. Now let us see how does it work. While transmission, a carrier frequency is used which is highly stable. Okay, of course it must be a stable so that the quality of the message signal will not be affected. We can generate carrier frequency from the oscillator, but whenever we need multiple carrier frequencies, if you want to use many carrier frequencies, then it is impossible to use the different oscillator circuit. நிறைய oscillator circuit போட்டு different carrier frequency generate பண்ணோம்னா நமக்கு காஸ்ட் அதிகமாகும், பவர் கன்சம்ஷன் அதிகமாகும். So in that case we can make use of this frequency translator. So by using the PLL we can generate different carrier frequencies shifted by the small amount from the reference frequency, right? Suppose you need a carrier frequency nearby that, you need a number of carrier frequencies with small deviations, then in that case you can use the PLL to shift the reference frequency by the amount whatever you require. That means you can translate the reference frequency into and generate new frequencies, that is frequency synthesizer. Okay, so உன்னோட reference frequency 1 megahertz இருந்தா, by shifting a small amount 1.2 megahertz for example, you can create by shifting the 1 megahertz to the 1.2 megahertz you can get 1.2 megahertz. Similarly you can get 1.4 megahertz, something like that. So a stable frequency generated by the crystal is called the reference frequency, and a number of other frequencies are generated from PLL. எப்படி இந்த மாதிரி generate பண்றது பார்க்கலாம், right? So using the PLL IC. So the block diagram is here, idea of frequency translation. The idea is very simple. You are giving your reference frequency here, right? Let it be 1 megahertz. என்னோட reference frequency 1 megahertz. So I am by simply your PLL with the external multiplier you can get the frequency translator circuit, that's all. With your PLL by connecting the external frequency divider circuit we got frequency multiplier circuit. But இது இங்கே வந்து அதே மாதிரி with your PLL by connecting the external multiplier you are able to get frequency translator circuit. எப்படி பார்க்கலாம். See here the idea is here is the reference frequency given FR. So your multiplier gives you the output with two different frequency. Highest frequency is F0. Actually to the multiplier reference frequency is given to the multiplier, and VCO out is also given to the multiplier. Okay, your multiplier gets two input, reference frequency and VCO output F0, right? So the output of the multiplier we know that multiplier, how does multiplier work? Multiplier generates highest frequency F0 plus V reference, highest frequency, lowest component F0 minus reference frequency, right? So highest frequency is F0 plus reference frequency, lowest frequency is F0 minus reference frequency. So through low pass filter I am allowing only the lowest frequency component, that is f0 minus reference, right. Now what is this T? Here only our phase detector compares this, the phase detector takes this as the input frequency and compares with the this frequency with the Ft. This is actually the translated frequency. How much you want to translate the reference frequency, that you have to connect here. For example, suppose இப்போ வந்து நீங்கள் உங்கள் reference frequency 1 MHz, நீங்கள் வந்து 0.2 MHz translate பண்ணணும்னு நினைக்கிறீங்க. So your output should be a 1.2 MHz. எப்படி பண்ணணும்னா இங்கே உங்கள் reference frequency 1 கொடுத்துட்றீங்க, ஸோ இங்கே 0.2 நம்ம கொடுத்துட்றோம். அப்போ இங்கே எவ்வளோ இருக்க முடியும்? கண்டிப்பாக 1.2 இருக்கணும். ஏன் அப்படின்னா, ஸோ when f0 is 1.2, so what will happen? Here you get 0.2. So it will be compared with the 0.2 and the output, if there is any error here, so based on the error voltage and VCO adjust towards the 1.2 frequency, right. So that is the idea of frequency translator. Externally multiplier and LPF are ordered. Input for multipliers and reference and VCO frequency f0. So reference frequency வந்து 1 MHz னு வச்சுக்கிறோம். நம்ம இப்போ வந்து அதை 1.2 MHz னு ஷிஃப்ட் பண்ண போகிறோம். ஸோ ஷிஃப்டிங் வந்து 0.2 MHz. So at the output of the multiplier we have number of frequency component. Highest frequency component is f0 plus reference frequency and lowest component is f0 minus reference frequency. So we are passing only f0 minus reference frequency out of the filter. So the external frequency is selected such that it is equal to translation required. Ft வந்து நமக்கு 0.2 MHz. எப்படி பண்ணுறோம் அப்படின்னா, ஸோ ஃபேஸ் டிடெக்டர் என்ன பண்ணுது, கம்பேர் பண்ணுது இந்த Ftவும் f0 minus reference frequency, f0 minus f, then it must be equal to lock the PLL. PLL lock ஆகணும்னா இது ரெண்டும் ஈக்குவலாக இருக்கணும். f0 minus f reference should be equal to Ft, right. That is f0 minus f reference is equal to Ft. Then what is f0? Ft plus f reference, right. So f0 is nothing but Ft plus f reference. Then what is this is nothing but what is your Ft? 0.2 MHz. F reference 1 MHz. Then your f0 must be 1.2 MHz. Okay. So this must be 1.2 MHz. So இங்கே வந்து 1 MHz, இங்கே 0.2 MHz. So difference is this is 1, f reference is 1 MHz, your f0 is 1.2 MHz, the difference is 0.2 MHz. So comparing with the 0.2 we are adjusting the loop. So this is nothing but your frequency translator circuit, right. So we have discussed the two important applications of PLL: frequency multiplier, frequency translator. So PLL ஓட வெளியே வந்து frequency dividing circuit போட்டு frequency multiplier circuit application பண்ணலாம். frequency translatorக்கு frequency multiplier connect பண்ணி frequency translator application பண்ணலாம். Thus the reference frequency is shifted from 1 MHz to 1.2 MHz in the locked condition, right. Now the output frequency is highly stable and translated from 1 MHz to 1.2 MHz. So we have achieved the frequency translation application using the PLL. Even in the instrumentation applications we generate number of frequencies from single reference frequency. There also it can, the frequency translators we can make use of it. Now I come to the conclusion that, so in this module we have studied in detail about the application of the PLL, whereas in the previous module we learned the working of structure and working of PLL in detail and how the PLC is locked, right, and and how the stable frequency is generated out of the PLL. So all these concepts we have learned clearly, and with that we have learned all the concepts given in the syllabus of the Diploma Electronics and Communication Engineering M-Scheme syllabus, right. So almost we have covered all the topics given in the M-Scheme syllabus, and but see, one thing is that if when you listen all the series of these lectures up to this module, 25th module, the sequence will be different, Okay, so I have covered all the content in your syllabus in a different sequence, easy to follow and easy to understand you, right, and but all the topics are covered which is given in the M-Scheme syllabus. So here I show you the, you can also see your syllabus, right. So linear integrated circuits, in the first unit it is given introduction to operational amplifiers. So in the earlier modules, from the first 7 module of this series of lectures, we have covered all these topics. Okay. So the introduction to the operational amplifiers and advantages, in different mode, how can you configure the op amp with the negative feedback, inverting mode, non-inverting mode, right, and op amp applications, summing amplifier, divider, voltage follower, current to voltage converter, instrumentation amplifier, waveform generators. Of course, this is the positive feedback circuits, right, all that we have covered. And the PLL is given as the third unit of the syllabus. Of course, we have completed this in the last modules only, right, and actually after that we discussed the digital to analog to digital converters, right. So in D to A converter we discussed the very important 2 circuits, binary weighted resistor method and R to R ladder D to A converter, and in A to D also we discussed the 2 important methods and successive approximation type, 3 important methods, the successive approximation type and dual ramp, okay, method, and flash type ADC. Also we discussed another monolithic IC 555 timer in detail in monostable mode and stable mode. Also the regulator, another monolithic IC regulator, positive fixed voltage regulator and negative fixed voltage regulator, also the variable voltage regulator, right. Finally we discussed the PLL in our lecture series. At last we learnt what is PLL and the basic principles of PLL, the block diagram, lock range, and how to lock the PLL to the stabilized frequency output, and phase detectors, low pass filter, voltage controlled oscillator, everything we learned about the PLL we have covered in detail. Also monolithic 2 important IC related to PLL, one is a VCO 566, right. So this is the monolithic IC, we discussed in detail about the pin diagram and basic block diagram of the VCO and how to configure it by connecting the external resistors and capacitor, how to control the timing we discussed in detail. And another monolithic PLL is a 565, right. So PLL we discussed the pin diagram, functional block diagram of this particular IC. Also finally at last we learned the applications, frequency translation, frequency multiplication, right. So how to translate your frequency to the nearest center frequency, right, to your input frequency range, and multiplication also we discussed by employing the frequency divider network in between the VCO and the phase detector. You will be able to configure your PLL as a frequency multiplier, right. So from this we understand that you have covered all your syllabus, all the 5 unit of your syllabus is covered in this linear integrated circuits given in the M-Scheme syllabus of 4th semester electronics and communication engineering. With this I conclude my lecture. Thank you.